given this function, sketch a graph. I asked you guys not to use your calculator. And the reason why I do that, I want you guys to start thinking, right? And then we're going to describe end behavior. Okay. Put your finger at the highest degree. Okay, pay attention. They call this a even degree polynomial. Say that. Even degree polynomials, you want to think about the easiest even degree polynomial. You guys already said it. 2. That means its end behavior means it starts up, ends up. Raise your hand if you knew that. So look. I already know the graph's going to look something like this. You see it? Okay, now, if your leading coefficient, the number in front, was negative, what would happen? It would be reflected, or you guys say down, or fancy words concavity, down, but this is positive. Does it make sense? Put your finger at the y-intercept. Your y-intercept is this, because if you put in x equals 0, that goes away, it's the constant. So I know the graph's going to go somewhere down here at -8. Does that make sense? Okay, I don't really know what the graph looks like. Let's just double check our guess. 4x to the 4th plus 2x minus 8. Now, some students even mention the words, it looks kind of quadratic-like, right? Same family, even degree. Now, pay attention. This does not mean even symmetry. Even symmetry, that means it folds. Do you see the difference? Even symmetry, this is even degree. So 2 different things. Okay, let's talk about our end behavior. Everyone say, always. Always, in the sentence frame for end behavior, you always have to have one to be positive infinity and one has to be negative infinity. Because when you see the words, as x approaches positive infinity, what direction is that saying, class? To the right, right? Draw your stick figure anywhere. As on the x-axis, you're going towards positive numbers over this direction. What happens to our graph? Where does it go, class? I'm just looking for the arrows. So blue, look for the arrows. Blue, see? Look for the arrows. What happens to our graph? Up. F of x approaches what? Positive infinity. As x approaches negative infinity, which direction? As you go left on the roller coaster, f of x approaches. Huh? As you go towards the left, you go back up the roller coaster. Okay, guys, this should make sense. Think about this. If they're both pointing up, that means these have to be the same. Does that make sense? Yeah. All right.